Hello, good evening. Hello, hello, am I audible? Hello, am I audible?
Yes, sir.
Okay, okay, let's start today's discussion. Is my screen visible?
Yes, sir.
Okay, okay, let's start today's discussion. Let's start with question number one. Uh, Among the possible staggered conformation of all the given erythroisomers, which of the following statement is correct? So tell me which one is the correct answer. What do you think? Do you guys know what is the staggered and what is the eclipsed conformation? Hello, hello, so tell me which conformation is this? Is this eclipsed or is this staggered?
Staggered.
Staggered. So the connecting groups are far apart from each other. Okay, so there is less steric interaction between them, right? And which conformation is this one? What you have drawn later? What is this? Eclipsed or staggered? The second one?
Eclipsed.
Eclipsed. Okay, so now tell me which one is the this one is staggered, right? So we are in according to question we are considering the staggered conformation, right? So tell me which one is the correct answer. Let's go through the options first. Okay, sorry. Okay, let's go through the options. Okay, the
Sir,
two.
option C is correct.
Okay, let's discuss that. Okay, so in the first option, it is saying that two staggered conformations are possible for the given conformer of the erythroamino alcohol. So is this correct? How many staggered conformations are possible? This is one. This is, and how others are possible? How many others are possible for this molecule? How many staggered conformation it can have?
So at every different angle, it can have a staggered confirmation.
Sorry.
At every different angle, it will be a staggered confirmation, right?
Yes, but yes, up to this is staggered conformation, and this another, this can have another this conformation. This is also possible one. So we have to fix one carbon first, then we have to rotate the another one. Okay. Okay, so how many staggered conformations are possible? This is one, right? This is another one, and this is another. Okay, so it is saying that two staggered conformations are possible, so it is not. It has more than two staggered conformation. Okay. In the second option, what it is saying that all the staggered conformations suffer from alkyl-alkyl gauge interaction. Is this so? See here, the two alkyl groups are far anti from each other, anti-periplanar. So there is no gauge-butane interaction between these two groups. So this option is also incorrect. So in the last option, we are saying that intermolecular hydrogen bond between NH2 and OH group is present in all possible staggered conformation. So in which conformation it is called? This one and this one. It has a particular name. It is called gauge, right? And this is anti. So in last option, it is saying that intermolecular hydrogen bond between NH2 and OH group is present in all possible staggered conformation. So whenever it is in the gauge conformation, then it can have a stable hydrogen bonding, intermolecular hydrogen bonding due to the closeness of the group. But in case of anti-conformer, the NH2 and the OH are far apart from each other. So the hydrogen bonding is not possible in this case. Okay, so this staggered conformation doesn't have intermolecular hydrogen bonding. So in option C, what we are getting that intermolecular hydrogen bond between NH2 and OH group is possible only in two staggered conformation. This is the right option. Right? Any doubt? Yes, somebody wants to say something. Shweta? Any confusion? Any doubt? Anybody?
Sir, I was late, so I Didn't get it.
Okay, you are late. Okay, so we are just discussing the first question. So you know that what is the eclipsed and what is the staggered conformation?
Yes, sir.
Okay, so we were discussing this question that among the following staggered conformation in the given erythromolecule, which one is the correct option? So in the option A, it is saying that two staggered conformations are possible for the given enantiomer of the amino alcohol. So definitely it is wrong, but it has the three staggered conformation, which I have already drawn here. Okay, two are the gauge, this one and this is the anti-conformer. So this is the wrong option, the first one. In the second one, it is saying that all the staggered conformations suffer from alkyl-alkyl gauge interaction. So it is also not correct. Right, in this conformation, let's say the ethyl and the methyl two alkyl group are anti to each other, so there is no gauge butane interaction in this case. Okay, so, and then the last option, it is saying that intermolecular hydrogen bond between NH2 and the OH group is present in all possible staggered conformation. This is also not possible because in antiposition, NH2 and OH are far apart from each other. So hydrogen bonding is not possible in this case. Only in the two gauge conformer where NH2 and the OH group are near to each other in the close proximity of each other, only there the intramolecular hydrogen bonding is possible. So option C is the right one. Okay.
Yes, sir.
Okay, let's move to the next question. So tell me, which is the preferred staggered conformation of the 1,1,2 trichloroethane? Anybody? Anybody? Okay, let's start with the option B. So this type of staggered conformer is destabilized by the Gauge-Butane interaction, like steric and torsional strain, right? So as the two bulky group are very close to each other, separated by the dihedral angle of 60 degree, so there is a interaction between these groups. So how many interactions are possible in option B in this conformer between the chlorines? I have already marked that.
Two.
Two. And here in case of the C, how many interactions are possible there between the chlorines?
Two.
Two interactions are there. And in this structure, is this at all that goes with the nomenclature?
No, sir.
Yes,
It's the one option one which is more preferable.
yes. In this case, only one interaction is there. So this is the stable conformer, right?
So why not D?
You just see that is it 1,1,2 trichloroethane? See, the three chloroatoms are in the same carbon atom. This is just given to confuse the students. Have you got it? See, the three chloroatoms are at the same carbon atom, but the is here that it is 1,1,2 trichloroethane. It is 1,1,1 trichloroethane, right?
Yes, sir.
Okay. So any confusion in this question?
No, sir, clear.
Okay. So let's move to the next question. Okay. So here it is saying that how many additional gauge interactions are present in case of the cis-decalin compared to the trans-decalin. So you know the structure of decalin system. Okay, I am drawing that. Okay, this is I am drawing in, it is the cis decalin. Okay, here hydrogen. Just go through the structure carefully. Okay, and when I am drawing it in the chair form, let's numbering the this carbon atom. This is cis decalin. Okay, this is cis, as you can see that the two hydrogen are in the same side, so this is cis decalin. And in case of trans decalin, the two hydrogens are in the opposite side. One is above the plane and another is below the plane. Okay, so the chair conformer of the decalin system is this one. One hydrogen is above and one is below. The same way we can number this system also. Okay, so now can you tell me from the picture, can you predict that how many Gauss butane interactions are possible here?
Sir, there are 15 Gauss interaction in cis and 12 Gauss interaction in trans.
Okay, so if we calculate the effective one, then in trans there is 0 Gauss butane interaction. And in case of cis, there are 3 Gauss butane interaction. So one is this one, another is this one, and the another is this one. So when these groups are in the close proximity, so there is a torsional and the steric interaction. So in case of the cis decalin, it has the 3 additional Gauss butane interaction compared to the trans. So the trans one is the more stable one and stabilized by the 3 Gauss butane interaction. So the right option is D. Okay. Okay, let's move to the next question. Now tell me, which is the correct answer? Which of the following molecule predominantly exists in the Gauss form of at the equilibrium? Anybody? So this is the general structure of all these 4 molecules, right? Where X is the halogen one. Okay. So now tell me, what is the cause of the interaction between these two groups? Means what kind of interaction it is? It is bonded interaction or non-bonded interaction? Hello.
Sir, non-bonded interaction.
Obviously non-bonded interaction. So we can say that as the size increases, okay, so as the size increases of this group, so the possibility of the interaction increases,
Yes,
right?
sir.
Right.
Yes.
So what is the size sequence of the halogen molecule? Which is the largest one?
Sir, iodide.
Iodide. Iodine means.
Iodine, correct.
Okay. So if we, this is the correct order of the structure.
Fluorine,
So,
chlorine, bromine, iodine.
okay, clear. Clear, na?
Yes, sir.
Okay. So from the structure, from the size sequence, can you predict that what can be our answer hint? I have given already the hint of the answer. Means if we see, this is the smallest one and this is the largest one. So which is probability? Means if here, if we put a smaller group, that will be more destabilized, or if we put here a larger group, that will be more destabilized.
Larger.
Larger, definitely larger. So here, if we put two iodine groups in the Gauge conformation, then there will be definitely a large amount of the steric interaction. So the structure will be destabilized, right? Is that clear?
Yes, sir.
Okay. And in case if we put here the fluorine atom, the smaller one, then the possibility of the interaction will be lower, right? So definitely in case of the fluorine molecule, it will tend to form the more stable isomer in case of Gauge, right? Than chlorine, bromine, and iodine. Okay. Is there any doubt?
No, sir. No doubt, sir.
Anybody? Any doubt?
No, sir.
Okay. Let's move to the next question then. Okay. The Gauge conformer of N-butane is disymmetric. Definitely it is disymmetric, only having C2 axis. Yet N-butane is as a whole is optically inactive. Right. Identify the most appropriate reason behind this. Okay. So tell me which is the can be possible answer. Let's draw first the Gauge conformer of N-butane. Right, these are the Gauge conformer. Is that clear? Now tell me, let's go through one by one option and we will analyze the statement. Okay, at equilibrium, the number of the achiral conformation, like this one, is greater than the number of the chiral conformations. Is this true? Hello?
No,
In the
sir. First statement is not true.
yes, because it is already stated that yet N-butane as a whole is optically inactive, right? So if the number of the achiral conformer is higher, then it will be optically active. Okay, so this is not the right option. Okay, so let's consider the option D. The N-butane exists as a non-resolvable DL pair. Is this true?
No, sir.
No, this is also incorrect. So, and the option B, it is saying that the molecule primarily exists in the anti-conformer, which is achiral, means this one. If it exists in the anti-conformer, then it can cancel out the optical rotation as it has the point of symmetry, achiral one. But can we go with this option?
Sir, as it is stated that 70% of the conformation is anti.
Yes. 70% is anti, right? But not 100%. So the other 30% exists as the Gauss one.
Yes, sir.
So we have to go with the option B. You can see that this one is the mirror image of the this one. The M gauge and the P gauge are the mirror image of the each other. So the optical rotation of the this molecule cancels
Cancelled out.
out by the optical rotation of the this molecule, right? So
Yes,
that
sir.
is why uh, this one is the option C is the right answer. At equilibrium, every chiral conformation like gauge has an energetically degenerate non-superimposable mirror image conformation, right? So as mirror, this one has the mirror image of the this one, so the optical rotation will be exactly same but in the opposite direction. So it is cancel out each other, and the molecule as a whole remains as the optically inactive one, right?
Yes, sir.
Okay. Yes, that you correctly said that 30% of the molecule remains as the anti, and this is the stabler one, as there is no interaction between the two adjacent methyl groups, and the remains 30% uh, stays as in the gauge conformation, P gauge and the M gauge. Okay, any doubt, anybody? Can we move to the next question?
Yes, sir.
Okay. Okay, so this is the here identify the conformations which can be termed as the M gauge. So let's discuss the common structure. So now tell me, this one is the gauge conformation, right? Any doubt? So tell me, in case of the this one, this is the gauge one, and this is also gauge one. Here the angle is 60° from the front carbon to the back carbon, and here it is 60° but in the different direction, like 300°. Okay, so now tell me, which one is the which gauge, which one is P gauge and which one is the M gauge? This one is M gauge or P gauge? This is termed as the P gauge. Okay, so from the front carbon to the back carbon one, the it is going clockwise 60°. So it is termed as the P gauge. And when from the front carbon to the back carbon, the dihedral angle is also 60°, it can be set it as 60° but anti-clockwise, right? So it is the M gauge. Any doubt, anybody?
So does P and M stand for something, or is it just notation?
It is just notation. You can you can remind as this one, this is plus and this is minus.
Okay.
Okay, this is as this is clockwise, right? And this is anti-clockwise. So you can remind as this one, it is positive and the negative, but you can, this is just a notation. Okay. Okay. So in case of this option, uh, like this one, this is the methyl group and this is hydrogen. This is also the 60°, but in the negative direction. So this is M gauge. And in case of the option 4, iodine and the hydrogen, this is also the same rotation. This is also the M gauge. So the correct option is option B. Okay, now tell me, in case of the 7, consider the following conformation of the erythro 2,3-dibromobutane. Okay, have you guys solved this? Here some Gauge interactions is given, like for the methyl-methyl, for the methyl-bromine, and for the bromine-bromine. Interactions are the given. So we have to choose the right option. Just tell me which one is the right option. What do you think? Let's first consider the structure 1, right? So here which interaction is this between methyl and the bromine, right? So how many methyl bromine interactions are there?
2.
2. So in case of the 1, we can write that the methyl bromine interaction causes 0.8 into 2, right? Right? And let's find out in case of the 2 how many is up there. 1 is bromine bromine, right? So for bromine bromine 3.0 plus for methyl methyl, what is the interaction? Is this clear? Hello.
Yes, sir.
Okay, so is this clear? That's 1 is for bromine bromine interaction. We have taken this one, and then for the methyl methyl and the bromine methyl, the 3 total interactions are there. It will have a substantial value, and in case of the 3, what are the interactions present here? Somebody tell me what are the interactions present here?
The bromine-bromine interaction,
Bromine bromine interaction, then
methyl-methyl, and
methyl
methyl-bromine.
methyl and methyl bromine. So this is the same as the 2, right? Right? The same interaction we found out in case of the 2, the same interactions are the present in case of the 3. Is this correct or not?
Yes, sir.
Okay. So what is the right option? In case of the select the correct order of the energy due to gauge interaction. So which one is the right option?
A is the correct option.
A is the correct option, right? So 1 is of the least energy, and then 2 and the 3 at the higher energy, and they are energetically degenerate, right? Anybody has any doubt?
No, sir.
Is this clear to everybody?
Yes, sir.
Okay,
Yes,
can
sir.
we move to the next question?
Yes, sir.
Sure, sir.
Okay. Okay. So here some statements are the given that which of the following statement is correct about different conformers at any polar molecule. So now tell me which one is the correct option. The first option is saying that different conformers of any polar solvent always have the same dipole moment. Can it be true? Means there is some Gauge conformation, there are some anti-conformation. Can it have the same kind of dipole moment?
No, sir. They have different dipole moment.
They have different dipole moment, right? So this is the wrong option. So we are just reopening the older slide. So just to explain the dipole moment, like you can see that in case of the anti-conformer, the two dipoles are in the opposite direction. Though it is methyl group, it has the not very significant dipole moment, but suppose it is in case of the methyl, we can consider it as the X, or any kind of halogen, any kind of polar group is present there in case of in place of the methyl. So in case of the anti-conformer, they are opposing each other, right? And they are cancelling out each other, right? But in case of the gauge conformer, they have the significant value, the resultant one. So definitely in case of the gauge and the anti, the dipole moment value will be same or different.
They will be different, sir.
They will be definitely different. Okay, so first option is wrong one. So in this case, tell me which one is the right answer. So in this case, the option C is the right answer. Whenever you can see that in case of the polar solvent, there is a solvent effect, right? Means the solvent may be polar or apolar, protic or aprotic. So it definitely it has some influence on the dipole of the conformer. But in case of the gaseous phase, definitely there will be no solvent. So the dipole-dipole repulsion present in any conformer is less significant. Okay, so option C is the right one in this case. Okay, so here it is saying that the select the correct option with respect to 1-chloropropane. So let's draw structure of 1-chloropropane. I am just drawing the staggered one, right? Have I drawn the right structure? Is this okay?
Yes, sir.
So this is the anti one, right? The chlorine and the CH3 are opposite to each other, and this is gauge, and this is also gauge. Okay, so let's start consider the various options. The most stable conformation is the gauge conformation, which is stabilized by the London's dispersive force, van der Waals attractive forces. So in case of the gauge conformer, there is some interaction, right, between chlorine and the methyl group. So will it be stabilized?
No, sir.
No. So then consider the option C. The most stable conformation is the gauge conformation, which is mostly stabilized by the intramolecular hydrogen bond. So is any kind of hydrogen bond is possible in the between chloro and the methyl?
No, sir. Because the condition of hydrogen bonding is presence of hydrogen and electronegative atom.
Exactly, the presence of some hydrogen and some electronegative atom. It can be OH or NH2 or any kind of group like
Yes.
so. So there it may form hydrogen bond, but here it is not possible. Okay, so the last option is saying that the anti and the gauge forms have similar stabilities. So is this true? Means
No,
in
sir.
gauge conformer there is some interaction, but in anti conformer they are far apart from each other, so they cannot interact between themselves. So the right option is
B.
B. The most stable conformer is the anti-conformation, which is stabilized by relief in torsional and the steric strain. So definitely they are far apart from each other. They cannot interact between each other, so they are stable. Okay. So anybody has any confusion? Anybody, any doubt? Is this clear to everybody? Can I move to the next question?
Yes, sir.
Okay. So here we have to discuss the energy dihedral angle profile of the C2C3 of the 2-methyl butane. So you first tell me, what does the starting point signify? Is this eclipsed or staggered? The starting point where we start the conformation analysis energy profile
Sir,
diagram.
it is eclipsed.
Eclipsed.
It is eclipsed, and then it is.
So this one is of lower energy and conformal, so it is anti.
We cannot say anti or anything. This is staggered.
Okay, we can say staggered. Okay, sir.
Yes, and this is again eclipse, staggered, eclipse, staggered, eclipse. Like here the dihedral angle 60°, here 120, here 180, here 240, here 300, and here again 360, like 0°. The same condition where we started. Okay. So accordingly, the backward carbon we move around clockwise or anti-clockwise, anything, so that we get the conformational energy of that particular conformer. Okay. So now tell me, how many interactions are possible here? How many Gauss-Butane interactions are present in case of this conformer of the 2-methyl butane?
2.
2. Here one and here this one, right?
Yes, sir.
And here how many? Here how many interactions are possible in case of this conformer?
Only 1.
Only one. And case of this one, there is also only
One.
one. Okay. So from this only the staggered conformer, we can say that the one of the conformer is definitely destabilized than the other two. Right? So this one is the gotch, this one is the anti, and this one is gotch. Like, okay. So if
Yes,
we
sir.
match with the energy profile diagram of this molecule, so we can put this molecule like this one, and this anti one is this one, and here the 2-methyl-methyl interaction, due to the presence of the 2-Gauss-butane interaction, this is slightly destabilized from these two, and the energy of this one will be higher than these two molecules, so it will be somehow above, this energy will be somehow above than the other two staggered molecule, and this will be here of this molecule due to the presence of the two phosbutane interaction here. Okay, so option C is the right answer. So now tell me, this is the similar one like the previous one. The number of the Gauss CH3 interaction in the most stable conformer of the 1,1-dibromo 2-methyl propane. So tell me, which one is the most stable conformer? Definitely the staggered will be the most uh, stable conformer than compared to the eclipse. So tell me, here how many bromine and methyl interactions are there in the first conformer?
Two.
2.
Yeah.
Two. One is here and another is here, right?
Yes, sir.
And in case of this conformer, how many interactions are possible here?
Only 1.
Only one. And in case of this conformer, only one interaction is possible, right? So what will be our right answer? The number of the Gauss interaction in the stable conformer will be
One.
1. Exactly. This is the same one like the previous one, the same kind of structure. So this one is the our last question of today. So consider the energy profile diagram of the N-butane octane from the C2C3 rotation. Okay. So what is the this one? A is what, which kind of structure the A represent?
Eclipsed.
Eclipse, exactly. This one, right? And then B,
Gosh.
Gauge. I am not drawing the hydrogens. Okay, here the blank spaces are hydrogen. Okay.
Yes, sir.
Okay, so here it is B, it is Gauge, and A it is eclipse. Then C,
Partially clear.
Partially.
partially
Exactly.
eclipsed. Exactly. Here is methyl, and here is methyl. Like, right? C. It is partially eclipsed. Why we are saying partially eclipsed? Because here hydrogen is present, and in case of original eclipse, there two methyl groups were eclipsing with each other. So you can check, that is why the energy of the A is much higher than the energy of C, where their interaction is between methyl and hydrogen, right? Can you correlate with that energy profile diagram? Have you got the point what I am trying to explain?
Yes, sir.
Yes, sir.
Here in case of the A, the methyl-methyl interaction is there. So obviously between because of the interaction of the two bulky methyl group, the energy is much higher than the C, where the methyl and the hydrogen are in the eclipsing position. Okay. So definitely, which is the right option? A is the only seen periplanar conformer in the diagram. Is this true?
No, sir.
No. In case of C, it is saying that B and E are the gauge conformation. Is this true?
No, sir. B
No,
and F.
sir.
No. B is gauge, but E is not. Right? So then it is saying that D and F are the anti-conformation. Is this true?
No, only D.
Only D is the anti-conformation. So the right option is
B.
B. C and the E are partially eclipsed conformation. As we see from the energy profile diagram, C and the E are the partially eclipsing to each other between the methyl and the hydrogen groups. Okay. So does anybody has any doubt? Can we conclude for today's class? Okay, then thank you for joining. Hope
Sir,
this. Yes,
kindly send me your email ID, sir.
I cannot send you the email ID. You
Okay,
can
okay.
tell me the queries in that YouTube channel link section. You can ask me, or from there
Okay,
you can also get my email ID. Okay.
fine, sir. Because, sir, some of the question of the previous week assignment I had solved, but there are some doubts. So that is
Okay.
why
Sure,
I was
sure,
on. Okay.
sure, sure, sure.
I will post. Can I post it on the YouTube video, sir? The comment section.
Yes, you can post it.
Okay. Thank you so much, sir.
Okay. Thank you. Okay. Thank you everybody for joining.